Hello, everybody. This is Tushar from Biotechnica. How are you all guys are doing? Hope you are doing well. So today I am back again with a series for Biotechnica. We have been running this Prerna series, which consists of previous year NEET questions. We have already completed 2 sessions in biology, 1 session in chemistry, and I'm back with the chemistry session with some great, excellent conceptual questions. And you should practice these PYQs before this exam. Connect soon with me so that we can solve these beautiful questions and gain knowledge from it. That would be very helpful for us on the day of the exam. So we have just 10 more days to go for the exam. Hope you are practicing the questions properly, revising it, and importantly, giving mock tests. So please connect with me soon so that we can start this session. We'll be starting the session in a couple of minutes. Join soon. So we have just 10 more days to go. So I hope you are revising your topics well. It is important that you simultaneously practice this PYQs because studying is different thing. Practicing giving questions and mocks is an important thing to it. Hi, Sneha. So we'll be waiting for 1 more minute and we'll start the session. Please join. In this 10 days period, you should move focus on PYQs. Okay, without any wasting for the time, let's start with the questions. So this is the first question. It's the correct sequence of bond enthalpy for CX bond. So we have first option as methyl fluoride, we have methyl chloride, we have methyl bromide and methyl iodide. You need to arrange these compounds in the order of bond enthalpy. Please try these questions out, solve them by yourself. To give you a hint, you can use the concept of bond length in it and solve it. I hope you can see the options. So the first option is, I hope you can see the options. Wait, let me get aside a bit so that you can see the options. Okay. Great there, take. Any Sneha? Yes, yes. Great. Okay, then let's see what's the answer. So the answer for this is option B, which is methyl fluoride is greater than methyl chloride, is greater than bromide, is greater than iodide. Now let's understand why it is. The important thing you should note here is bond enthalpy. Now, you know, bond enthalpy is similar to bond strength. The more the bond strength, more will be enthalpy. Now, as we move down the group, when we move down the group, the size of atoms increases. Now, you see from fluorine to iodine, the size increases. Now, if the size will increase, the bond length will increase. Now, for bond length, we know bond length is inversely proportional to bond strength. So, we have the highest bond length for methyl iodide. So, we will have the smallest bond strength. Hence, it will have the smallest bond enthalpy. So, we'll have the highest bond enthalpy for fluoride, followed by chloride, bromide, and then iodide. It's great, dear tech. So next, move to the next one. So the next question is, find the major product for this reaction. So we have 3-methyl butene plus HBr in the presence of peroxide. So please solve this question, at least make your own approach. You might get it wrong, but it is important to make your own approach while solving these questions. Then only you will understand the concepts better. So please make your own attempt in solving these questions. I'll wait for a few minutes. So I can give you a hint in this. You can use anti-Markovnikov rule. You can use anti-Markovnikov rule in this. I'll wait for a couple of seconds. You can use anti-Markovnikov rule here. Great, Sneha. Other guys, please involve yourself in this session. Please try to solve questions more. It will help you to develop approach to it. So moving to the answer is yes, A. Yes, Sneha and Devatek, yes, it's A. Now coming to anti-Markovnikov rule, it says protons will be added to the carbon with the least number of hydrogen atoms. Now if you move to the question properly, we have two methyl groups here, CH and CH2. Now you can see here we have two protons, here we have one proton. So what does anti-Markovnikov rule says? It says proton will be added to the carbon with the least number of hydrogen atom. So hydrogen will be, this double bond will be removed, hydrogen will be attached to this carbon and bromine will be attached to this carbon. So we'll get option A as the correct one. Clear? Now, I just want to add one more thing here. It is happening because of the peroxide that we have. Now, peroxide will help to move this mechanism to the radical one. Now, let's say we have the same thing. Let's say we have this with a normal HBr without any peroxide. It will go Markovnikov rule addition. Clear? So that's just one more extra point that I'm adding. Suppose if it is not there with peroxide, only HBr is there, so Markovnikov addition will be there. Okay, so let's move to the next question. So the third question is hydrolysis of sucrose is given by the following reaction. Sucrose plus water will give glucose for fructose. If the equilibrium constant is 2 into 10 to the power 13 at 300 degree Kelvin, what is the standard change in Gibbs free energy? Please try to solve this question. It is one of the simplest questions. You might be hesitating by seeing these large options, but it's one of the most easiest. I can give you a hint. You can use the formula for Gibbs free energy. Okay. So moving to the options. Yes, dear take Sneha, great. Okay, you got it correct. It's option A. So what it requires, it has given us equilibrium constant. Kc is given to us. We know the temperature is 300 Kelvin and we need to find standard Gibbs free energy at this temperature. So what do we know? At equilibrium, we know Gibbs free energy, standard Gibbs free energy is minus RT ln Kc, where R is my universal gas constant, T is my temperature, and Kc is my equilibrium constant. Okay, now you just have to plug in the values into it to get the answer. Now for the minus is minus, for R is 8.134, temperature is 300, and in place of Kc we will be using the value Kc equal to, it's given in the question, 2 into 10 to the power 13. So yeah, so the answer A is correct. So moving to the next question, the statement 1, acid strength increases in the order given as HF is less than HCl, is less than HBr, is less than HI. And statement 2 is as the size of the elements fluorine, chlorine, bromine, and iodine increases down the group, the bond strength of HF, HCl, HBr, and HI decreases, and so the acid strength increases. Now, which of these statements are correct? A, B, C, D. I'll wait for a minute. Please try solving these questions with me. And once I discuss the answer, then you will know what mistakes or you have made or what you have done. So you can enhance your knowledge in that way. Yes, Sneha, Dirtek. Okay, Sneha is saying option A, Deertek is saying both are incorrect. So let's move to the answer. It's answer A, which is both the statements are true. See, I'll explain it. The first statement says the acid strength increases in the order HF is the least acidic, HCl, then HBr, then HI. Now, as I have already mentioned in one of the question, as we move down the group, from fluorine, chlorine, bromine to iodine, the size increases. Now, if the size will increase, the bond length will increase. Now, if the bond length is increasing, I have already said that bond length is inversely proportional to bond strength. So when we have a more larger bond, its strength is less. So that bond can be dissociated more easily. So what is this acidity? Acidity is nothing but its ability to grip the proton. So if the bond will be more easily breakable, so that agent or that compound will give easily the acid, or it will be more acidic. So that is why our HF, which has a stronger bond, will be less acidic in comparison to HI, because its bond length is more, so bond strength is less, hence its bond length is more, so bond strength is very less, so it will easily dissociate to be more acidic. Okay, so this is how statement 1 is correct. Now the same reason as I have mentioned here, as the size of the element from fluorine, chlorine, bromine increases down the group, the bond strength of HF, Cl, Br and Hi decreases, and so the acid strength increases. Okay, I hope you got this question. Moving to the fifth question, the correct increasing order of basic strength for the following compounds. Now here three compounds are given: aniline, para-nitroaniline and para-methyl-aniline. You have to arrange them in their basic strength. Please try to approach this question, because these questions are very common in NEET. In basicity, even you can have questions in acidity as such. So these questions are very important and fundamental questions. Approach these questions. I'll waiting for a couple of seconds. Be with me till the end of the session, and in the description below you can check a list for all the important topics for NEET. You can get that, and that will help you to revise more quickly for the end terms. Yes, Deertek is saying 3 is less than 1 is less than 2. So that's basically option D. Okay, Sneha, electron donating group, basic strength. Okay, then let's move to the answer. So answer is option D. Option D, 2 is less than 1 is less than 3. So let's see here. Okay, we have here aniline. Okay, so what is this basic strength? Basic strength is the ability of a compound to donate its lone pair. So you must keep in mind how easily these lone pairs are donated, how easily this compound can donate its lone pair. Now we have aniline here, another compound, we have nitroaniline, and the third we have methyl in a para position aniline. Okay, so you can see here nitro group. Nitro group is a electron withdrawing group. Okay, so what does it will do? It will involve this lone pair in conjugation with the system. So this lone pair will not be readily available. Okay, in comparison to this aniline. Now with the last option, this with the methyl group, we have a plus I group, that is methyl. Although it's in para position, but still it will have some impact rather than the normal aniline. So the most basic will be the one with this methyl group attached, because the methyl group will increase electron density in the ring. So the lone pair will be more available for donation. Then the aniline will come, and then the nitroaniline comes for the last. So highest will be C, highest will be third, then option highest will be third, then option 1, third, option 1, and then 2. You get this? Okay. So it will be option B. Third will be highest basic. I hope you got this answer. Third will be highest basic, followed by third, correct the order of increasing bench strength. So third will be most basic, then followed by option 1 and followed by option 2. So sorry, we have got this 2, D. So 2 is less than 1 is less than 3, correct? So option D, correct? I hope you got this answer correct. Moving to the sixth question, the product formed in the following reaction. So here we have sodium borohydride in the presence of ethanol. Okay. Please try to solve this question. Here you have to decide between the reactivity of two things. I'm giving you a hint, between ketone and between a ester. Okay. Okay, Deartek is saying option A. Other guys, please ping in the answers and try to solve with me. Okay, I'll wait for a couple of seconds. Sneha is saying option B. Yes, Deartek, it's a reducing agent. Sodium borohydride is a reducing agent, correct? BH4. NaBH4. Okay, moving to the answer, it's D. So, sodium borohydride is a weak reducing agent. Sodium borohydride is a weak reducing agent. Okay, so now you have to compare the reactivity between carbonyl and between the ester. So we have a ketone group here. I'll just change the ink. We have a ketone group here and we have a ester group here. Now tell me which is more reactive in terms of the electrophilicity. So we know ketone is more reactive than ester group. So sodium borohydride, which is a weak reducing agent, will reduce only the ketone. So it is only reduced and this changes to alcohol. So we have the correct answer as option D. So moving to the next question. The next question is the intermediate compound X in the following reaction is methyl when reacts with chromyl chloride to give X, and when it is hydrolyzed in acidic condition, it gives aldehyde. Please try this question. This is an important question from aromatic systems. I'll give you a couple of seconds to move in. I hope you're enjoying this session. Please involve in this session and answer questions with me. I'm waiting for a couple of seconds. After the session, you can check in the link below in the description box. You will get a checklist of the important topics. You can easily revise and complete the revision from it. Yes, Deartek, option A. Great, Deartek. You have identified the reaction correctly. It's Itard reaction. Excellent. Okay, then let's move to the answer. So the answer, as rightly pointed, it's option A. It's the famous Itard reaction in which the toluene is oxidized to benzaldehyde in the presence of chromyl chloride. I'll just write the step for you. It's toluene. When it reacts with chromyl chloride, in the first step, it will form only one hydrogen will be substituted. And when you do the reaction further, the another H will be substituted and we will get the option A as the intermediate. Okay, so two of these systems will be written. I'll write here for the clarity for others to note. The intermediate form will be this. Okay, so you have rightly said this. It's option A. So moving to the next question, the correct option for the value of vapor pressure of a solution at 45 degrees C with benzene to octane in molar ratio 3:2 is, which of the options are correct? 160 mm of Hg, option B, 168 mm of Hg, option C, 336 mm of Hg, option D, 350 mm of Hg. I'll wait for a couple of seconds. I'll just give you a hint. You need to use Rawls law here. Rawls law. These are important concepts from solid and colligative properties. You need to revise questions. These are the important questions that every time we see in these exams. Okay. I'll wait for a couple of seconds. Please do solve with me in this session. You will be finding your approach. You will know your mistakes. You will rectify it. You will learn more. Okay, then let me move to the answer. So I'll solve this first, then we'll come to the answer. So what it is given, okay? It is given that we have benzene to octane ratio in mole ratio 3:2. So what does this mean? This means we can assume we have benzene 3 moles, we have benzene 3 moles, and we have 2 moles of octane. Okay, now what does this Rawls law says? Rawls law says the vapor pressure, the total vapor pressure PT is equal to the partial pressure exerted by benzene B in the vapor state and the partial pressure exerted by octane in the vapor state. Now, what is this partial pressure of B, which is benzene? It is nothing but the partial pressure of benzene in the pure form, which I have represented here, Pb naught into mole fraction of benzene plus partial pressure of pure octane into mole fraction of octane in this. Okay, so you can find, it is already given in the question that moles for benzene is 3, moles for octane is 2. So what is the mole fraction for benzene? It's nothing but 3/5. Okay, what is the mole fraction for octane? It's 2/5. So we have got our mole fraction. Then we just have to add this with the question we have here for benzene, pure benzene, the partial pressure is 280 mm, and for octane it's 420 mm. Okay, so here we can add for benzene is 280 into 3/5, which is the mole fraction for benzene, plus for octane it's given in the question 480 into 2/5, the mole fraction for octane. Now once you solve this, you will get 336, which is option C. Okay, I hope you understand this concept. It is important. Once again, I'll just repeat it from the Rawls law. Total partial pressure, the total vapor pressure for the solvent is given by the partial pressure for benzene in the vapor phase plus the partial pressure of octane in the vapor phase. Okay, I hope you got this answer. Let's move to the next question. Choose the correct option for the total pressure in a mixture of 4 gram O2 and 2 gram hydrogen confined in a total volume of 1 liter at 0 degree C. Given the universal gas constant is given to you and the temperature is given to you. The options are A 2.518, B 2.602, C 25.18, and D 26.02. Try solving these questions. This is a simple question. You just need to know an important equation which is very basic to physical chemistry. Okay, I'll give you a hint. You need to use the ideal gas equation. Okay, use the ideal gas equation. It's the simplest of the questions. Just it's framed in a way that will scare you out. Okay, Sneha is saying option A. Other guys, I hope you are solving these questions. Try and solve it with me. You'll come to know about your mistakes. You will rectify them. You will learn more. I'll wait for a couple of seconds. Okay, then let's move to the answer. Answer is option C. Let me explain it. Okay, as I was saying, you need to use ideal gas equation, which is PV equal to nRT. Okay, what is P? It's pressure. What is V? It's volume. N is number of moles of gas. R is universal gas constant, and T is temperature. Okay, now the key question involved here is you need to find the number of moles of gas. Okay, so it is given here. It is given here 4 grams of O2. Now what is this 4 gram of O2 will come in number of moles? It is 4 by, what is the molecular mass of oxygen gas? It's 32. So the number of moles for NO2 molecule will be 1 by 8. Similarly, 2 grams of hydrogen. How much moles it will be? We know the mass given by the molecular mass. For hydrogen, it's 2. So we'll be having 1 mole of hydrogen gas. Okay. Now we just need to put these values in the option, in the formula and equation and get the answer. Okay. I'll solve it for you. So we know PV equal to nRT, which means what we want to find? We want to find pressure. So pressure will be equal to nRT by V. Okay, just put in the values. For number of moles, we have 1 by 8 for oxygen and 1 for hydrogen, plus the value for universal gas constant is given. Okay, it's 0.082 into temperature. The temperature is 273 degree Kelvin divided by the volume. Volume is 1 liter. Okay, now put these values and solve it. You'll get the answer to be option C, that is 25.18. Okay, I hope you got this problem. You just need to find the number of moles from oxygen and hydrogen. Okay, and you must remember PV equal to nRT. This is important. This is the most basic thing in physical chemistry, ideal gas equation. Okay, so let's move to the next question. The next question is the slope of Arrhenius plot ln K versus 1 by T of first order reaction is -5 into 10 to the power 3 Kelvin. The value of activation energy of the reaction is, so options are given. Option A 41.5 kilojoule per mole, option B 83.0 kilojoule per mole, option C 166 kilojoule per mole, and option D 83 kilojoule per mole. Try to solve this question. These are most frequent questions and conceptual questions that you will get. I'll wait for a couple of seconds. You need to use Arrhenius plot. Okay, I'll give you a hint. The Arrhenius equation is rate constant is equal to Arrhenius constant e to the power activation energy by RT. You can derive that equation plot from this equation. Okay, Dare Take is saying option A. Other guys, please try solving these questions. These are more conceptual questions here. Correct. Yes, dear tech. Yes, the slope is given by negative activation energy by R. Okay, let's move to the solution. So as I have already said, activation energy, the rate constant K is equal to Arrhenius constant A e to the power activation energy by RT. Now, if we convert that into the logarithmic ln natural log, we'll get ln K equal to ln A minus EA by RT. Now, this is my Y, okay? This is my C, this is my M and X. So for your convenience, I'll arrange this equation for you. Minus EA by R 1 by T plus ln A. Okay. Now you can better notice that Y equal to MX plus C. Okay. So what is my slope? What is my slope? My slope is negative activation energy by R. Okay. Now we can just move to the question and look for the activation energy. The first order, it's given the slope. The slope for the first order reaction is given. So we have slope equal to minus EA by R, which is equal to minus 5 into 10 to the power 3 Kelvin. Okay. So minus and minus will cancel out. EA is equal to 5 into 10 to the power 3 into the universal gas constant R. You can just put the value. R is 8.314. Okay. Once you calculate this, you'll get option A, 41.5 kilojoule per mole. I hope you got this answer. Okay. Moving to the next question. Which of the following molecule is non-polar in nature? Option A, POCl3, option B, CH2O, option C, SbCl5, option D, NO2. Try solving with me. I'll wait for a couple of seconds. The non-polar molecule, mark these words, non-polar in nature. Think why a molecule is called non-polar. Okay, I'll just give you a hint. Dipole moment. Check the dipole moment. These questions are important because it's asked in this fashion, non-polar moment, non-polar in nature. So dipole moment, check the dipole moment. Okay, Sneha is saying option C. Other guys, I hope you are solving with me. Gertek is saying option B. Okay, let's move to the answer and check it. So answer is option C, SbCl5. Now see why it is happening. Let me explain you. For POCl3, as I've said, why a molecule is nonpolar? A molecule will only be nonpolar if it has zero dipole moment. This is important. This is the take-home message that you get from this question. A molecule will be nonpolar if it has zero dipole moment. Okay. Now let's try to draw the structure and understand it. POCl3, for POCl3, the structure of the molecule is like this. Okay. Now, as you can see, it will have a resultant dipole moment. The dipole moment is not getting cancelled. It's non-zero here. Okay. Coming to CH2O, it's nothing but your formaldehyde, carbonyl, H and H. You can see here the dipole moment direction is this. So here also the dipole moment is not getting zero. Okay, let's move to D, option D, nitro. Here you can see the dipole moment here is also not getting to zero. Now let's check for the option C, SbCl5. Sp in between, Cl up. These are axial CLs, and these are triquetral CLs. Now you can see here this and this gets cancelled out. Okay, and in this triangular phase, in this planar molecule, the resultant will be cancelled. So this has effective dipole moment of 0. So this molecule, so SbCl5 will have 0 dipole moment and it is non-polar. I hope you got this answer. Let's move to the next question. From the following pairs of ions, which one is not an isoelectronic pair? Option A, O2 2 minus, fluoride minus. Option B, sodium plus, magnesium 2 plus. Option C, manganese 2 plus, iron 3 plus. Option D, iron 2 plus, manganese 2 plus. I'll wait for a couple of seconds. Note on this point, isoelectronic pairs. You must recall what are isoelectronic pairs. Try solving these questions with me. Their take is saying option D. Okay. Other guys, please ping in and solve the question. Wait for a couple of seconds. Option D. Okay. Now we only have 10 days at our hand. So practice more PYQs. So let's get the answer. The answer is option D. Now coming to the point, the most important point, isoelectronic pairs. Now what are isoelectronic pairs? Isoelectronic pairs are atoms or ions. Those have same number of electrons or same valence electrons. Okay, this question is very easy. Just need to understand what does this point means. What do you mean by isoelectronic pairs? So let's check each pair. For option A, O2 2 minus and fluoride minus. For oxygen, it's 8 since we have 2 negative charge, plus 2, it's 10. For fluoride, the number of electrons is 9, plus 1, it is 10. So it has the same. So it's an isoelectronic pair. Note in the question what it is asking. Note what it is asking in the question. It is asking not. Give importance to these statements when you are reading the question. In a hurry, you should not make a mistake. Okay, so you need to stress your not. So option A is isoelectronic pair. Let's move and check option B, sodium plus and magnesium 2 plus. Okay, for sodium it's 11, the atomic number, plus 1, so loss of 1 electron, so it will have 10 electrons. Correct. For magnesium it's 12 electrons for it, but since it has 2 plus charge, so it has lost 2 electrons, so it will have 10. Now again, it's an isoelectronic pair. Let's check for the option C. It's manganese 2 plus and iron 3 plus. For manganese, it's 25. 25 plus 2, it means it has lost 2 electrons. So it will be reduced to 23 electrons. Okay. For iron, the atomic number is 26. Since it has lost 3 electrons, 3 plus means it has lost 3 electrons. Okay. So it has lost 3 electrons, so it will be 23. I can see this is the isoelectronic pair. Now coming to the last option, which is iron 2 plus and manganese 2 plus. I have said earlier, iron is 26, it will lose 2 electrons, so it is 24, and manganese is 25, it will lose 2 electrons, so it will be 23. So you can see it's option D. This is not an isoelectronic pair and others are isoelectronic pairs. Okay, so let's move to the next. So the next question is, BF3 is a planar and electron deficient compound. Hybridization and number of electrons around the central atom respectively are. Option A is sp3 and 4 electrons around the central atom. Option B is sp3 and 6 electrons. Option C is sp2 and 6 electrons. And option D is sp2 and 8 electrons. Try to solve this question with me. You can use the hybridization number to find the hybridization of this atom. I'll wait for a couple of seconds in between. Now, this hybridization number, the steric number, VSPR theory, these are important concepts in organic chemistry. You should revise them regularly. You should practice more questions on them. In NEET, every year we get small questions, easy questions. You just need to find this hybridization number properly. Okay, their take is saying option C. I'll wait for a couple of seconds. Okay, so let's dive into the answer. It's option C. Let's understand it, how it's happening. Okay, so we have BF3. Now, how to find the hybridization number for it? The hybridization number is half into number of valence electrons of central atom plus number of monovalent atoms. Monovalent atoms. Okay. Now, what do we mean by monovalent atoms? Monovalent atoms are those atoms that have valency of 1. Okay. For in this case, it's fluorine. Okay. So, for the hybridization number for BF3 is half. For bromine, electronic configuration is 5, which is 2, 3. So in valence shell, it has 3 electrons. Okay, 3 plus we have 3 monovalent fluorines attached to it. Okay, so 3. So we have 6 by 2, which gives 3. So we know for 3 it is sp2. Okay, for 3 it is sp2. Now let's count the number of electrons around it. So B, F, F, and F. Now boron has 3 electrons in its valence shell, and fluorine will be sharing 1 electrons around it. So it has 6 electrons. Okay, so it is sp2 and 6. I hope you understand this question and answer. So the take-home message from here was you must know how to find hybridization number. Okay. Moving to the next question. Among the following alkaline earth halides, one which is covalent and soluble in organic solvent is option A, calcium chloride, option B, strontium chloride, option C, magnesium chloride, and option D, beryllium chloride. It's a very good and a conceptual question. I'll wait for a couple of seconds for this. I can give you a hint. You need to use Fazen's rule. Fazen's rule. Fazen's rule is an important concept. Many questions in a twisted manner come in this form. They will be having the same concept, but the questions will be framed in a different manner. Okay, so this is one kind of question that can be framed from Fazen's rule. I'll wait for a couple of seconds. I hope you are solving these questions with me. It is important you solve more and more PYQs, because once you solve more questions, you will develop the approach, the way to solve these questions. Okay, their take is saying option B. Other guys? Okay, so let's get to the answer. The answer is option D. Okay, so I'll explain you why it is happening. So what is Fagen's rule? So Fagen's rule exclusively says no molecule is 100% ionic or covalent. Okay, now the rule, I'll explain this rule in a simpler way. You just need to remember one thing, Scylla, SCLA. Okay, small cation, large anion. Okay. Small cation and large anion gives covalent. The covalent character increases. Okay. This you can understand and remember like a mnemonics. Okay. Scylla, small cation, large anion. Once you remember this, you can solve any question from Pageant's rule. Okay. So now what do you have? We have beryllium, magnesium, calcium, and strontium. Strontium. Okay. We have this. Down the group, the size, the chlorine is constant. Okay. You can see the chlorine is constant. So what I have said, small cation. Okay. Which is the smallest cation in this group? The beryllium is the smallest cation. Okay. So since the beryllium is the smallest cation, since the anion is fixed, so only the deciding factors will be the size of the cation. The smallest the size of the cation, the compound will have more covalency. Okay. So the correct option is beryllium chloride. Okay. Okay. So I hope you got this option correct. One more thing just to add in this point, why this is happening. Suppose we have beryllium. Now, if it has smaller size, it will have a more nuclear pull. So it can pull more electrons from other. And since if we have a larger atom, chloride or something, then it can pull towards it. So there will be more sharing. This electron cloud will be more shared. So it will increase the covalency. Okay. So let's move to the next question. Find out the solubility of nickel hydroxide in zero point 0.1 normal NaOH, given that the ionic product of nickel hydroxide is 2 into 10 to the power minus 15. The options are 2 into 10 to the power minus 13 molar, 2 into 10 to the power minus 8 molar, C, 1 into 10 to the power minus 13 molar, and option D, 1 into 10 to the power minus 8 molar. Try solving this question. This is an important and a conceptual question. I'll give you an hint. First, try to dissociate this. Write the equation for dissociation of nickel hydroxide. Okay. This question is from ionic product. Solutions ionic product concept. I'll wait for a couple of seconds. This is a good conceptual question. I'll wait a couple of seconds more, then we'll go into it. Find out the solubility of nickel hydroxide in 0.1 normal NaOH, given that the ionic product of nickel hydroxide is 2 into 10 to the power minus 15. Try to solve this question. Okay, let's move into the answer. The answer is option A. I'll explain it. So as I have written earlier, nickel hydroxide dissociates to give nickel 2 plus and 2 hydroxide minus. Okay. Now in the question, okay, they are saying option C. Let's see. In the question, it is already given nickel hydroxide in 0.1 NaOH. So in the solution, along with nickel hydroxide, 0.1 normal NaOH is present. Okay. So this is the nickel hydroxide dissociation. The NaOH, sodium hydroxide, will dissociate in a similar fashion. Na plus OH minus, and it is 0.1 molar NaOH. So it will dissociate to give 1 molar Na plus and 1 molar OH minus. Okay. Similarly, for nickel hydroxide, as I've written earlier, it's nickel 2 plus 2 hydroxide minus. Okay. Now let's say the solubility of nickel hydroxide is S. So it will dissociate to give S for nickel 2 plus and 2S plus hydroxide. Now, what is the effective concentration of hydroxide? What is the effective concentration of hydroxide? The effective concentration of hydroxide in the solution will be 2S from this, and from NaOH we will have 0.1. So effectively we will be having 2S plus 0.1. This is the effective concentration of OH. Okay, and so we know ionic product IP. Ionic product is given by concentration, product of concentration of nickel into concentration of hydroxide square. So just put in, we know we have assumed this to be S for nickel. So it is S into, for hydroxide, it is 2S plus 0.1 square. Okay. Now you can see here one important thing to note here that will help you while solving the question. You can just note here that the ionic product is given in 2 into 10 to the power minus 15. So you can see the order. It is 10 to the power minus 15. It is very, very less. It is very, very less. This 2S, this 2S is very, very less than the 0.1. Okay, so we can just rewrite this equation. Ionic product is equal to S into, since it is very, very less, 2S can be neglected, so it is 0.1 square. Okay, so we can just plug in the values. For ionic product of nickel hydroxide, it is 2 into 10 to the power minus 15. So we can write 2 into 10 to the power minus 15 is equal to S into 0.1 square. Okay, when we solve this, S will get here 2 into 10 to the power minus 13. Okay, so it's option A, 2 into 10 to the power minus 13. Okay, I hope you got this answer. So once again, the important take home message from this question was, when you are dissociating along with this, nickel hydroxide, you must remember that you also have NaOH. Okay, so the total concentration, since we have OH here and also we have OH here, so both OH will be there. So in total concentration, you need to consider this. Okay, I hope this question is clear. Okay, so we have completed the 15 questions from this, and we will be bringing more such conceptual questions in more series to go. In this, we have just 10 more days to go, so keep practicing more questions. Believe in yourself that you can do this exam. Don't fear, don't think about all other results and all. I know it will be very difficult for you to focus, but try your best to remain motivated. Think why you started this journey, to get clear NEET. So focus on that, solve more questions, give more test series, and you will be having a great confidence ahead. Thank you all for remaining with me with this session. In this description below, we will be having a checklist, important topics to be covered. Okay, please do download that and revise it. That will be a bonus to you. Okay, thank you all for remaining with me. We'll coming up with such more sessions ahead. Thank you.